you want me to get started? All right, it's time. Let's get started. So, just like last time, we have Professor Venkata Subramanian here, who is a computer science professor. Some of you missed that when I said that last time. He is a professor of computer science, not philosophy.
I just do a good job thinking.
Yeah, so we're going to continue our discussion from last time, and we will start by discussing your reading assignment.
Okay. So I mean, it's also a good point that, you all think that I teach philosophy in full time, even though I don't. I've only been studying this stuff for probably about a few years, which is a good thing because it means that, for when I'm talking about these issues in class here, you're thinking, well, I came here to study computer science. I don't want to study all this other stuff. And I would not blame you for thinking that, but it's actually not that difficult to understand the larger ramifications of the work you do. I would say it's important, which is fine, but it's also not that hard to get into it and really understand how these issues, these larger ethical issues affect the work that you do. And I think it's important that you sort of think about that. So, take a class in philosophy or just read a lot, and you'll start beginning to realize that there's a bigger world out there that complicates some of the things that you do. And on that note, I think we sort of created some scenarios last time in class. And of course, we did that deliberately so that we could give you the reading to tell you, okay, what's really going on. These are not artificial scenarios, these are real scenarios that we're dealing with right now. And so I guess I'd like to hear from you all your reactions, thoughts, feelings about the readings, both on the Facebook case and also on the credit score that's being deployed in various parts of China right now. Anyone? I'm happy to take any kind of, yeah, go ahead.
First thing I thought of with the China
okay,
one.
okay,
I'm sorry.
That's fine. We'll go for it and we'll take it next, yeah.
First thing that came to mind is just how big of a trade-off it was for the China one. There are incredible advantages to what they're doing in some ways, but there's also incredible costs. And kind of what we talked about yesterday, there really is a trade-off between...
Could I ask you to name one good and one... So you said benefits and costs. Can you name one benefit and one cost in your mind?
One benefit that I saw is it is definitely a deterrent for crime in certain crimes.
Deterrent for crime?
If you know that there's an immediate negative response to any of your actions that are being monitored all the time.
So like the jaywalking thing?
Right, like jaywalking. But there's also great costs that reduce privacy and all kinds of other things.
So deterrent to crime is a positive in your view, and reduced privacy in your view is a negative?
It could be to some people.
Okay, so plus and minus. Okay, let me write that down. I think this issue of trade-off is very, very important, and I'm glad you brought it up. Yes, something on the back.
One thing I just thought was really sort of insidious about the Sesame credit score system is that all of the consequences involved are positive. It's all rewards, which I feel like, I don't know how that plays into an ethical conversation, but I feel like that makes it easier to get something that would normally not be accepted as the...
So you're saying from a kind of a psychological or sociological point of view, the idea of phrasing everything in terms of rewards is effective and therefore in your insidious. Because you're viewing something negative about this, even though you say it's effective.
Yes.
So what is a negative thing? I mean, you use the word insidious, right? So
I mean, part of it is that if they ever decide to add punishments, now you're punishing any form of belief that does not line up with those in charge,
right.
Which limits the number of ideas and beliefs in society as a whole, which can do serious damage.
And so the insidiousness is sucking people into the system with rewards, and then bringing out the whammy and saying, okay, now we have. Is that what you're referring to? Okay. Let's see from this side. Yes.
Well, I'd like to point out that they are putting more punishments in there.
So it's already happening.
Yeah, like for one, they limit the travel of people who have low scores, and I think they didn't let them get passports, didn't let them buy train tickets or plane tickets, like put them on a blacklist. So, yeah, I mean, like that's going on.
So are you somehow implying that the addition of punishments is the problem here? That if it was just rewards, it would be okay?
No, I'm just clarifying what you said.
Okay, that's already happening. Okay.
Yeah.
Let's see from this side. Anyone from this side? Okay. Yes.
It seems to me that a lot of the categories they have are very subjective. So it's like one of them is for doing exemplary business, you get 30 points or whatever. It's just like it doesn't seem very well defined. And so it could be, it could be used to, punish somebody, or if someone's not doing exemplary business, you want to punish them, for maybe not agreeing with what you think. Like maybe one person has the power to do that. I'm not sure exactly.
So your complaint with this is the lack of objectivity.
Right.
And the subjectivity has the potential for manipulation and bias.
Right.
That the more objective the system were, the less of a problem this would be.
Mm-hmm.
Is that a fair characterization of what you're getting to?
Yeah, but it's also, they're trying, I guess maybe trying to make certain things objective, which maybe there's a lot of shades of gray, like trying to make things black and white, and it's not possible.
So I want to highlight this point a little bit. On the one hand, you're saying that subjectivity is rife or potentially rife with abuse because people can interpret things the way they see fit and incorporate various elements of bias in it. On the other hand, you're also saying that the attempt to force objectivity on some domains that are inherently subjective itself is problematic because there's no real way to define certain things. Which leaves us in a very interesting conundrum there. Because on the one hand, you're saying we want to be more objective, on the other hand, there are things that just are fundamentally not objective at all. So what do you do in such a situation like that? How do you reconcile this fact that you want to make things objective, and you kind of have to make things objective, you're going to use an algorithm, because a piece of code needs numbers, it needs something more precise than opinions. But there are things that are just, you get the sense that there are just things in our life that are fundamentally not objectifiable. Yes?
I just think, like I was reading an article and it seemed like there were some systems that were more objective and some systems that were more subjective. And I think the more subjective it is, it's more of a slippery slope. And that's when you get into racial biases, and maybe not even racial biases, just biases in general, or just promoting your agenda. If you have a beef against someone, you can use, and you're in a position of power, you can use the system to make their social standing worse and limit their travel and everything. So I think the system could have benefits if it's implemented objectively, which I saw more in the Rongcheng, I think, the city, than like some of the other villages.
So for you, objectively means there's a very clear and well-defined formula in some sense.
Yeah.
This good behavior gets you 30 points. That bad behavior loses you 20 points, or something like that.
Yeah, and like with behavior can, like good behavior can be loosely defined. I think one of the examples was like, okay, you paid your bill on time, that's like 30 points.
So that's very clear, right?
That's very clear, and it's not like, oh, you did something good.
So you would prefer to have very clear markers like that.
Yeah.
And that in your mind would make this a little bit more palatable than having more vague sort of guidelines. Okay. Yes, your hand is up. Go ahead.
So I had a couple of thoughts, but along the lines of the objective versus subjective, I think that in a lot of ways it could be both, and I feel like even in this class we learned how to do tests of our own code to make sure that we print it, and especially since there are a lot of sciences that look into this kind of stuff, sociology, criminology, all that other stuff, that we can create tests or maybe kind of re-examine stuff like this every so often or at intervals to kind of see like, hey, is this thing being racist? Is this thing being transphobic? Is this thing being X, Y, and Z? And I think it's important to keep in mind that I feel like a lot of people in general have this idea that a dystopian society is going to look more like the book 1984, where it's like Big Brother and everybody's scared. But it's actually becoming much more like Brave New World, where we're kind of spying, we're giving up our own information in a lot of ways, but people are wanting to play the same.
Mm-hmm.
And one of the, along the lines of what he was saying with the Sesame one, is that it's not really the government that's oppressing people who dissent, it's other people. And social pressure, as you all learned from all kinds of different programs in school, social pressure is the most effective kind of pressure. Being isolated from your peers is really, in a lot of ways, the most effective way to control someone's behavior. And in some ways, the most insidious form of almost of either who we're talking about.
Okay. No one has commented yet on the Facebook readings. I'm curious about why that was. Did you have a comment on Facebook?
Yeah.
Did you also have a comment on Facebook?
No, I was just going to say something about the time.
Okay, why don't you finish it quickly, then we'll go to his thing. Yeah, go ahead.
Okay, so one of the things, like I'm just to remind myself of something I'm putting into the article, one of the lines is that the exact methodology is a secret. And that is something
your solution?
Well,
Publish
I'm very
code?
good for that. If you're going to have something like this, I don't want it to exist in the first place. But if you're going to do it, I would at least like to know what the explicit rules are, and I want them to be laid out on somewhere where I can get them. So that way a standard citizen can know what increases or decreases their score.
So, for example, if you wanted to go and live in a city where they have a score, you'd be presented with a 50-page terms of service, a TOS, and you'd read through all 50 pages very carefully, because we all do that. And then you would sign at the end, and then you'll therefore give your consent to these rules. Except there's going to be 50 pages of code or 50 pages of weights of a neural network, and that would be okay, right?
I still wouldn't like it, but it'd be better than not knowing what is in the terms.
Good. It'd be better. You're not saying it's great, but it'd be better. Okay, I can
I
exactly.
still would dislike it, but it would be better.
It'd be better. Okay, yes. Go ahead.
Yeah, so on the Facebook thing, we were just talking about this just with our row and about the part about how they were saying that people who are putting houses on the market can use the Facebook advertisements to only show it to people who don't have an affinity to Hispanic or to African American. And Natalia was like, oh, that's a good thing. Like, I want to see more ads, you know. And so, but I was just thinking, like, that can kind of be a good thing or a bad thing because I think nobody in here likes ads. And so I think it's not necessarily a bad thing if people are like excluding us from their ads. I think as long as it's limited to ads, but once it's limited to maybe news or things like that, then that's a problem.
So I think what you're saying is that you don't view ads as being of particular value, so therefore you're quite happy to not have to see them. Okay. The reason why these things are considered illegal is because they were being used, at least in the non-electronic form, to prevent people from seeing anything that would allow them to find housing in a certain area. So I want to live in a certain area because maybe my job is nearby, or there's a good school district, and I get to see no ads for any kind of housing in that area. At that point, is that a good thing or a bad thing?
That's a bad thing.
So how do you know the difference then? Maybe you're in a position where you can afford to say, I don't need to see ads because I have many ways of getting the information I want. Maybe someone else doesn't. And I think that's where the issue comes in. And I'm going to talk about this a bit more in a second, but I'm glad you brought that point up, right? This issue of, maybe it doesn't affect me, but it affects someone else. And how do we think about this? How do we think about this appropriately as being good or not in that context, right? Yes?
So I just think I need clarification. So what exactly is the difference between what the article was saying that Facebook is doing and like targeted ad campaigns that any advertiser is going to use? That they target specific individuals, they target specific groups.
Right.
Because they want to reach those niches. What exactly is the difference between those two areas, and why is what Facebook is doing?
The very glib answer to that question, and by the way, I'm not saying what Facebook did was illegal. This is a point of contention, right? Whether Facebook would argue that they did not do anything illegally, advertisers did something illegal. So I'm not saying they didn't, but to answer your question, I think the short answer, the least satisfying answer I can give you, is that one is illegal and one is not. In other words, discriminating against groups for housing is illegal. Showing groups different ads for a movie. So for example, I forget the name of the movie recently, but it was basically different trailers were made for the movie to target different groups, to attract different people to different aspects of the movie.
So was Facebook only showing those ads to those denominations?
Facebook was showing ads to whoever they were asked to show the ads to.
Okay, so it's not like a targeted ad campaign that everyone can see, but a targeted ad campaign only that group.
Right, right. So different ads. So technically, if I show different groups of people ads for the same movie but with different information in the ad, there is no law saying that this cannot be done. There is law specifically around housing, right? Around the Fair Housing Act, for example. And so that's a glib answer to your question because it sort of sidesteps the issue of what's right or wrong. It's about what's legal and not legal, and that's not the same thing. I think your question more generally is, what is the difference between targeted ads and opportunities? I think this is not a resolved issue. I think this is something that we discuss. It is something that we have to figure out and we have to talk about. Is that, is there, if you are, in some sense, if you are limiting opportunities for advancement of some kind, is that more of a problem than just advertising for a new concert? Or maybe the concert is important because you're a budding musician and you want to go to the concert to get access to, scouts who might be, I don't know. So these are things you have to, it's not clear. And like most things, it's not completely clear what's wrong, and that's why it's good to talk about these. Okay. I like all these points that have been brought up here. I think we're going to touch on these points as we go on in the lecture. But I also want to bring up something to bring this back to some of the ethics discussions we had yesterday, right? So we were looking at what I would consider sort of toy examples, right? Is it good to lie or not? And we were trying to break things down. And I did that precisely to illustrate that from different points of view, you can come to the same conclusion. Conversely, from the same point of view, you can come to different conclusions. For example, in a utilitarian framework, depending on how you assign costs to different things, you might assign something as either bad or good, or ethical or unethical, based on your calculations. But what complicates things in a world that we live in today is that it's not even clear what the objects of our ethical discussion really are. When you're talking about, say, animal rights, I think there's general agreement on what the animal actually is. In the case of data, in the case of the kinds of things we're seeing with Facebook and these credit scores, it's not even clear what the object of study is. And let me give you an example, a couple of examples. So all of what we talk about is about data, whatever that means, right? Data, we're using data, we're hiding data, we're stealing data. There's this thing in the, every couple of years the business community decides to create a new thing around data. So one of the things that came up a few years ago was data is the new oil. Okay? It has to be mined. We mine the data. We extract value from the data. We refine it. All these metaphors kind of sort of work in a certain sense if you want to sort of sell things a certain way. If you think of data as oil, right, the ethical questions surrounding data are tricky. Now data becomes some kind of natural resource. And whoever gets access to it first, like in a gold rush or some other kind of mining rush, has access to it. Right? And the trading around data has no sort of ethical content to it because it is merely a commodity. So by defining data as the new oil, you essentially take away any discussion of ethics because it's just, we're discussing oil. There's no ethics of oil as such. Of course, there are other reasons why this metaphor is both appropriate and horrifying at the same time. We won't get into that. But suppose you change the focus. You say, no, data is not oil, data is property. Data is personal property, right? My data is my thing. It's like my house, my car, my data. At that point, discussions around data become discussions about rights. We get into social contract theory. Talk about, every individual has rights. If you take away their data, you are taking away their property. We have the right to our own property, and there is a problem here. And this gets you into things like privacy and, who gets to own your data and things like that. Okay, that's another way of thinking about it. Another way of thinking about it is data as a public good, right? So you have to, you want to collect genome samples, gene samples from 1 million people so you can build some database to help you do precision medicine studies. Right? This 1 million-person initiative that the Obama government put through a couple of years ago. In that case, the data as a public good is a very different notion. The notion of ethics is now around experimentation, right? There's some kind of good that will come from working with the data. But there's also, potential risks involved. And now you have to think through the ethical boundaries of using the data from a scientific perspective. So depending on how you view the problem that you're dealing with, the ethical considerations you have turn to be quite different. So let's look at the Facebook example, right? A lot of the issues with what Facebook was doing was they were taking what looked like people's personal data and doing things with it. So this whole issue of personal rights and privacy became the issue. Of course, what got lost in the shuffle and with all the congressional testimony and everything was the fact that it wasn't even so much that Facebook was giving away data, because they actually weren't. What they were doing was giving away inferences. They were giving away stories about people. In some sense, what they were doing was creating a persona for you and selling that persona to other people. In some sense, they were keeping the right to define who you are online. They were taking control of your digital identity, at least in this form. That's a very different kind of ethical discussion now. Do I have the right to my own digital identity? Do I have the right to the way I'm perceived in the world? Some would argue public figures don't have a right to the way they're perceived because they're public figures. What about all of you? Do you have the right to your own thing? In Germany, for example, there's a law that says that you have the right to be forgotten. If you can sue essentially Google, and Google has been sued a couple of times and had to do this, if they have information about you that is now very old or is in some ways incorrect, you can sue them to have it removed from the search engine, that they can no longer return those results when people ask questions about you. This will not work in the US, but in Europe, and especially in Germany, this is a constant thing. People are suing Google and other search engines to remove their information about them from the search database. Is this ethical? Suppose someone wants to remove information about them that makes them look bad. Is that a good thing or a bad thing? These are all issues that change the way we think about the ethics of working with data. Okay? And that's one thing to think about. Another thing I want to bring up is this issue of, it came up here, I didn't write this down, but the issue of where these rules are coming from and who is controlling them. So in the case of the social credit scores, right? So there was this whole idea of, oh, we want to do this to improve the way we think about credit, to improve the way, so to facilitate better transactions because everyone can trust a local bank or a local company that they are worthy of a loan because you have a better credit score, which is great. But of course, there's other side effects where certain groups of people could be affected in a negative way, separately from this positive aspect of getting better credit. And at that point, you have to ask whether we put these rules up or whether they're subjective or objective. Who gets to decide? Who has the authority or the power to decide these rules and who doesn't? Who is affected by these rules and who aren't? These are, so when we talk about ethics, we're not just talking about what's right or wrong. We're talking about who's involved in the decision-making process. And this is particularly important because as computer scientists, we are the ones, you are the ones who will be out there writing the code that at some levels is making decisions of these kinds. In some sense, you are taking decisions in your own, the way you write your code. That will affect people. Do you have the right to make those decisions? Should you have the right to make those decisions? Who should be making those decisions? This is the larger question that you have to ask when you think about the ethics of working with data and working with code and the ethics of a digital society and so on. Okay. So to think about this a bit more in detail, what I want to do is talk a little bit, I don't know if many of you have taken a course in machine learning or have read something about it or plan to do some machine learning at the U. We have a number of different courses. How many of you have some vague familiarity with machine learning? I'm just curious, I've done some. Quite a few of you, okay. What I'm going to do is, for the next 15 to 20 minutes or so, give you everything you need to know about machine learning. This is high level. So because what I don't want to do is get mired in sort of technical details, but I want to give you a high-level view of how we think through the process of building models to predict things. And I'm going to try and do it at a level where you get some sense of how it works, but also you get enough of a sense that you can see where some of the problems are going to come. Okay. And this starts getting closer to the question of what are we trying to do about some of these problems and how are we going to fix them. And this gets closer to some of the research that I'm doing as well. So you can think of this as the last bit will be sort of a shameless plug for some of the work that I do and a lot of other people are doing right now who are concerned about the deployment of various tools of these kinds. Okay. All right. So, machine learning. Very short primer. So, when we talk about machine learning, and again, I encourage you to sort of not think about buzzwords like AI, or deep learning, neural net. Just forget all those things. Okay? They don't really, at some level, they don't matter. But what does matter is the idea that what you're doing with machine learning at some level is sort of computational epistemology. What do I mean by that? What I mean by that is you are trying to use computers to know. You are trying to embody knowledge in the form of code. Knowledge that you actually may not have yourself. What does that mean? So I want to build a system to predict whether people will be good credit risks. I don't know how to build a system that will predict whether people will be credit risks. But I have lots of data on whether people were good credit risks in the past. So what I want to do is basically take all that data that says, this is a person, and they were a good credit risk. This is another person, and they were not a good credit risk. And I have all this information about this person, I have all this information about this person, all the features we talked about last time. And then put it into some gigantic thing which outputs knowledge, outputs a rule, a magic formula that will then tell me for a new person whether they're a good credit risk or not. Right? This is machine learning. This is all we do. When we do machine learning, we are trying to learn rules to make predictions. If you don't learn, there's no learning. If you're not making predictions, we don't care. Both these things are important. And these predictions are used, of course, to make decisions. If I'm trying to predict whether you will like a movie I recommend to you on Netflix, it might be annoying, but I'm not really worried about that. You'll live if you get a bad prediction. But if the prediction is being used to make some decision that is materially going to affect your life, then I do care about it. And those are the kinds of things we're going to be talking about. And these are complex things, right? I mean, you can imagine what makes someone a good credit risk. This is, as you imagine, a very complicated thing. It might vary a lot from person to person, place to place, culture to culture. And somehow what we want to do is somehow put all this information into this black box and have it spit out a rule. So how does this work? Right? So let's take the easiest possible thing. And sadly, this is, this might seem trivial, but this is also a lot of what people actually do. We'll talk about a problem called linear classification, or even linear regression. So what does it look like? So I want to say, I want to predict the likelihood that someone will re-offend after I release them from jail. Again, this is not a hypothetical, because these are systems that are being implemented and deployed in practice. So on the x-axis, or on the many x-axes, think of this as a very high-dimensional system, I have all the information about the individual. I have all these different people, I've collected data on them and what they did after they were released. And on the y-axis, I have some information about, how long it took them to re-offend if they did. Maybe I plot some things. I have some kind of, and this is very stylized, right? I mean, because there's not one dimension here. But imagine I have something like this. I have a bunch of points like this. And I want some kind of rule. Now you might look at this and say, oh, here's a rule. So I'm going to straight line here, right? This is a rule because now if a new point comes in, I can look at the new point and say, okay, the new point is here. The output of the rule will tell me I should be here. And I didn't know this ahead of time. So it's a rule that allows me to predict. But this is not the only rule I could have put here. This is one rule. Another rule could be, there's also a rule. It'll give me different answers from the first rule, but it's a rule. It seems to work with the data. I could have a third rule that goes something like this. These are all rules. As of now, there is no reason for you to pick any of these rules over any of the other rules. They're just all different formulas that allow me to make a prediction for something I don't see in the future. Now, of course, sort of intuitively or aesthetically, you feel like the straight line is a better rule than the others. You're not able to say why, but you kind of feel like, okay, that seems like a better rule. And there's a certain formal argument as to why it might be better, in the sense that it doesn't do something that we call, the jargon term, overfitting. In other words, the straight line kind of follows the trend of the data, but it's not overreacting to the points. And this is important because if tomorrow I get a new set of points, right? So let's say I had another graph here, and I had another set of points that look like this. It may be that the same straight line that worked today will kind of work tomorrow as well. But my more wiggly line that worked today would look very different from the wiggly line that worked tomorrow. And if I believe, and this is a judgment call I'm going to make, that I want some sense of lack of reactiveness to the daily sort of change data, then I would prefer the straight line over the curvy line. But that's still a choice. And the important thing here is that you have to make a choice. You have to decide, of all the possible ways you could give me that answer, the rule, what kinds of rules am I willing to look at? So I might say, I only want rules that look like straight lines. So it could be this rule, or this rule, or this rule, or that rule, and then among the different straight lines, I can decide which is the best straight line that captures my data. Or I can say, no, I only want rules that look like a quadratic equation. So among all the different rules that look like quadratic curves, I will choose the best one I can get. But I have to make that choice ahead of time. So I make that choice. I have some class of what I call hypotheses or hypothesized rules, and I want to pick one rule from this class of rules. And that's going to be my answer. Okay? Now, how do you figure out what a good rule is? Well, a good rule is one where it kind of matches the answers from the data you had before. Right? So the most simplest version of machine learning, I'm giving you the old data, I'm giving you the answer. This person, went and committed a crime after 6 months. This person went and committed a crime after 10 months. And I have all these answers there ready, waiting for me. So at the very least, I want my hypothesis to match what the data is already telling me. And so I can check, okay, this got it right here, got it wrong there, got it right here, got it right there, and I can tally up all the answers. So I get some notion of the accuracy of a rule. So for any rule I pick, I can look at its accuracy. And now I can say, maximize overall H, the accuracy of this rule H. And that's basically, that sort of sums up most of machine learning. Choose a class of hypotheses, choose a way to measure how good a hypothesis is, find the hypothesis that maximizes them. That's pretty much it. Everything else is just hype. And now again, like I said, these are all choices we make. We make choices about this, we make choices about this, we make choices about which features to include in our data when we build this model. That's also a choice. But why should this work for us? Why should this be at all reasonable? All I'm saying is, let me find a rule that matched everything I saw in the past. And if you do any investing, past performance is no prediction of future experience. Why should this work? The only reason we believe that this kind of system works is because we make one more assumption. We assume the past does look like the future. That things more or less stay the same. That whatever data I have access to reflects the world as it is, as it was, and as it will be. So once I build this rule, it will continue to be the same. That's a big assumption, but we do make that. Otherwise, we wouldn't be doing this in the first place. Right? Be able to pattern match what we saw in the past is not going to help us in the future unless we are claiming that some of the world has not changed. And I want you to contrast this with how you do prediction in the scientific world. So now you're let's say Galileo or you're Newton, you're trying to figure out what is it that makes things fall. You could, if you were doing machine learning back then, you would collect a bunch of examples of things falling and make some claim on it and say, okay, I've got this rule and I'm done. Yeah, it makes some mistakes back then, but it's fine. Or you'd say, no, things are falling, I need to know why they're falling. What is it that's making things fall? And then use that to derive a prediction. So you can either use your data and put it into some black box to make a rule, or you can try to understand what is it that connects the data to the outcome. Right? What is the mechanism that connects this to this? What is it that makes someone want to default on a loan? What is it in their psychology? What is it in their society and culture that makes them want to default on a loan? And spend a lot of time trying to figure that out to build a new rule. That's a more sort of inductive, well, that's a more, I wouldn't say inductive, I won't say deductive either, but it's kind of a bit more deductive approach to it because you are still trying to understand what underlying mechanism, causal mechanisms are. Whereas here, you're just saying, I will find patterns and see if the patterns look good. The surprising thing, of course, is that machine learning has been very effective. Without really knowing why something might be a good predictor, it turns out to be a pretty good predictor for many problems. And that's why people use it all. So let me give a simple example of this. So let's see. Where's my example? Now, I want to write down a simple example for you. So this is, we were talking about recidivism prediction. So here's an example. This is what comes from trying to train a set of rules for predicting whether someone will reoffend within 2 years of being released from jail. Okay? So this is the rule. I'll explain this in a second. So these are rules. You take some data, you build a model, and the model looks like this. There's a particular kind of set of rules called a decision rule. There are different kinds of hypotheses. I told you different H's. You could have straight lines. You could have rules. You can have rules like this. It says, okay, if the person's age is between 18 and 20 and they're male, they will reoffend within 2 years. If they're 21 to 23 and they've had 2 to 3 prior crimes, they will reoffend within 2 years. If neither of these things are true, but they have 3 or more priors, they will reoffend within 2 years. If none of these things are true, then they will not. These are the kinds of rules that are actually used when someone is about to be released on parole to decide what form of release they should have. This is based on collecting data from prior arrests and prior behavior, and then building a model. This is an example. So this is a very sort of simple example of how, and so these rules came up because it sort of maximized some function of accuracy on some prior data. So, I don't know. What do you think about this? Well, how do you feel about being the person who's being evaluated this way? Yeah.
So, having a little bit of background in criminology and whatnot, this ignores a lot of these rules, sort of blatantly ignore a lot of recidivism research. So, like, these might be true, but it ignores the fact that, especially the American prison system actually tends to pretty greatly ignore a lot of the sociological and neurological research that's been done over the last 20 years about effectively reducing recidivism rates. Sorry, that's when people go back to jail. So these rules are kind of, I don't know how to examine as a general, create another sort of algorithm to examine things like this and go like, is it relevant? This is true. It's a statistic that does kind of work out, but if you're ignoring kind of the core issue of why this is happening, this doesn't really address that.
So my response as a person who builds software like this is to say, I don't care about the core reason. I have data. From my data, I can build this model. It's very good at predicting the outcome. I don't know why it's doing it, but it's working. The algorithm has figured out something that I cannot figure out. Yes?
So I guess you have to look at where the data is pulled from. So to start out, I don't necessarily agree with this because let's say it was pulled from a population that doesn't have treatment programs.
That doesn't have what?
Like treatment programs, for example. If they don't have that, then it's going to pull these. Well, let's say you're in a prison with a treatment program. Now you're being pumped into these groups.
So you're saying that depending on the data used to build this model, you could generate different outcomes?
Yes.
Or different rule sets?
Yes.
That is true. Yes?
Well, I think that that would be one way of trying to break this model. If it's consistent across.
Are you trying to break the model?
I mean, that's how you prove science. You try and break it.
So your goal is to see, is this model effective by seeing where does it not work anymore? Is that what you're saying?
Exactly.
Okay, good.
And so, like, just pull it from different situations and see if it's still consistent.
Yeah.
If it's still consistent, then that means that there's really something going on here, and that it could be generalized, even though it would be nice if there's more going on and we could vary that to reduce the rate of reoffense.
So I've heard this now twice. The goal is to reduce the rate of reoffense. Is that the goal? Did I say that was the goal?
In this case,
That is a goal. I agree. Do you know if that's the goal being used to build this model?
I think no.
Because the goal here is really to predict whether someone will reoffend. It makes no opinion. It has no statement about whether we want to reduce reoffense rates or not, which is another good point because what you're trying to do is an important issue. Yes.
I was going to say, I think it's great, it's awesome, because when you're thinking about yourself and you're being subjective, you would think, oh, I would never do this, but it's like, oh, I fit into these criteria, so maybe I should watch it. You know, it's just a predictor, and if it's a good predictor, then we should use that information to inform our decisions more objectively.
If it's a good predictor, we should use it to inform our decisions more objectively. I like that. It's a very clear framing of this question here, which is good because you can agree or disagree with it in a very clean way. So thank you. I thank you for saying that. Would someone like to respond to this? Yeah.
The problem is sometimes you can have biases baked into the model itself. I know at least one example where I think IBM was training a facial recognition software using machine learning, and they said they were all white people, and the facial recognition software could not recognize African Americans because the data used was biased.
Yep. If you want to hear, you should go to gendershades.org to hear more about that work. It's actually very fascinating work. So I guess the question is, what is good? What is objectively good? You know, do we know, or can we know how good this predictor is if we are merely measuring its accuracy on data? Before I take more comments on this, so this is merely one example, right? But this is an example of, this is not a bad example of many of the situations where we're using machine learning, whether it's for whether you should be given bail before you're before you put on trial, what kind of sentence you should get, whether you should get parole, whether you should be selected for further screening for a job, whether you should get admission to college, whether you get a loan. We've seen some of those things already. Almost anything you can imagine that sort of substantially affects your life is now being sort of modified by algorithms because it's we have data. Why not? And that's where the world we live in today. So I'll take maybe one more reaction before I want to move on. Yeah. Let's see, way back in the back there. Yeah. Yeah.
So the problem isn't with the algorithm or the data itself. Data is neutral.
Data is neutral. Wait. I want to write that down. I like clear statements like this because they're easy to sort of, like I said, either agree with or disagree with. Go ahead.
So there's nothing implicitly good or bad about the data or the algorithm. What we should be looking at is the intention and the consequences of it, and whether or not it's reflected with our other values. So if we took an algorithm like this and applied it to whether or not people will commit a crime, and say, well, we're going to look at each person, and if they meet these criteria, we'll imprison them before they commit the crime.
Yeah.
I think people would have a lot bigger of a problem with that. But why is it that that's the case, but it's okay to do it if they're already a prisoner?
I don't know. If we are so confident of our model, why should we not run a Minority Report 100? So as you can see, right, when we start deploying algorithms for decision making, there are all kinds of issues that come up, right? There's the issues of where the data is coming from. There are issues of what the intentions of people are. There are issues of what is the underlying mechanism that appears to be causing this to happen. There's the issue of are we sure we've trained this properly with the right models? Have we chosen the right hypothesis space? Are we missing something? There's all these issues that come up, right? Unfortunately, most deployments are not really thinking about these things, right? So for example, there's a tool that's being used right now for pre-trial risk assessment where it's trying to predict whether someone will show up in court or not for the hearing. Okay, so this is a binary outcome, right? Yes or no, they will or they won't. And the success rate, what they do is this tool basically assigns people to 6 levels of risk. So from 1 to 6, 6 being the highest risk of not appearing in court, 1 being the lowest risk of not appearing in court. These numbers come from an actual probability. So the model predicts the probability of the person showing up in court, and this is converted to an actual number. At least in one version of this tool, the probability of not showing up in court that gets you to high risk is something like 20%. In other words, if there's a 1 in 5 chance that you may not show up in court, you're deemed to be high risk of not appearing in court. There is another tool that's used to do recidivism prediction, where the tool is being used and it's defended because the success rate, and remember there's a binary outcome, right? So it's a yes or no, they will or no. The success rate of the tool is something like 60%. And you should keep the 60% in mind when you think about what a coin toss would do for you. If you just tossed a coin every time a person showed up, you'd get roughly 50% success rate. So a tool that has something like a 60% success rate is what is being used in practice to decide whether people should be released on parole or not. And I can give you more examples of this guy. So this is the scenario we're in today, where we're using machine learning because of its perceived effectiveness all over the place. In places where we haven't fully yet thought through the ramifications, the ethical ramifications of using tools that have errors, tools that are built on certain kinds of data sets, and who gets to decide whether these tools are deployed or not? Who gets to decide what the rules are for these tools? And so I guess that is my segue into sort of this area of research right now that I'm involved with, where many, many people are working on, across disciplines, not just computer science, across many disciplines, to try and understand some of the issues that come up in this area. And so I wanted to maybe talk about sort of this whole issue in sort of 4 parts, right? And sort of explain some of the things that people have come up with, and some of the places where I think computer scientists have much to offer to help push this discussion forward. So it's not, what I don't want to do is create the impression that, oh my God, we're building terrible tools and need people to come and slap us in the wrist and tell us not to do it. I think that what's happening here is that there's an opportunity to build better tools, tools that are actually good, that actually can help people, that actually are reasonable to use. And that's what we're trying to push sort of this exploration forward to. So that's what I want to sort of tell you a little bit about. Okay, so this whole area has got many different names, depending on who you're talking to. But there are sort of some key elements here that come from the discussion that we talked about, and I want to sort of write them down here. And they come under what are generally considered these areas, which are called fairness, accountability, and we talked a little bit about that. Interpretability, which also relates to a larger issue, what I'll call transparency. And again, these words sort of overlap a little bit, right? And I want to bring this back to sort of some of the discussions we've been having about these actual tools and how they work. So think of some of the questions you can ask, right? So you're out there building some tool for doing something. Maybe you're building one of these tools to do prediction of, say, credit score risks and so on. And the first thing you'd like to do with your tool that you build is try to understand, well, what the heck is my tool doing? When I have a tool that sort of makes some predictions, and I'd like to know why it's doing what it's doing. Now, this might not, so this is what is generally considered to be sort of the realm of what I'll call accountability or explainability. And think of it the following way. If someone were to give you a black box that said it could predict I don't know, whether someone will do well in college or not, or whether they're likely to drop out within six semesters of joining. They're actually, even the U has tools like this that they use to sort of run models on people to see what they're going to do. If you are one of the people building these tools, what you would like to do is try to understand how it's working. Try to understand whether it's picking up on certain patterns that are real or patterns that are fake or patterns that make sense or not. So there's this whole area. So, and again, to understand this, it's helpful to understand, and again, some of you may have heard of neural networks or may not have. For the purpose of discussion, imagine a neural network as this gigantic black box with, let's say 50 million different knobs in it. It's a big dashboard, 50 million knobs. And by adjusting these knobs, when something comes in, you can make a prediction, say a yay or nay on the outside. Okay? So there's a big dashboard of knobs. You turn them, and then you keep turning them for a while, and after a while you're happy that your system is predicting things like that. And this is basically deep learning. Okay. Alright. If you have such a system, how do you know whether it's picking up on a real pattern? So to explain what that means, let me try to give you an example of where this could go horribly wrong. So we talked about this IBM example. I think this is a good one here. So this, again, if you haven't heard the story, basically it's not just IBM, Microsoft, and a couple of other companies have built face recognition tools. Okay, so the idea is you have these pictures, and you want to be able to recognize if there's a face in the picture. So not recognizing who's in the picture, we just want to recognize that if there's a face in the picture. If you ever come in from outside the country, you know that you have to go to one of these immigration booths, and there's a machine there. How many of you have done this? So you sort of move the thing up and down, and it scans your face and says, okay, I see you now, and it does this thing, right? Okay. It turns out that a lot of these tools are very bad at detecting faces that are not basically white males. Especially if they're dark-skinned, or if they're different ethnic groups, other kinds of things. They will not be able to detect them. And why is that? What is going wrong in my system that it could do something like that? Remember what I tell you about machine learning, right? You get a bunch of data, you build a model based on the data you collect. You get a question? You got an answer.
Yeah.
Even better.
The data was built based off
that, again, I don't know why this is the case. That's as good a conjecture as any. But definitely the case is that the data being used to build a model. So I have some data coming in, which is being used to build this model. The outcomes of the model here. This data is questionable. Right? When we build these tools for machine learning, we don't the way we actually collect data is we have some data lying around, or we get everyone in the office to sort of scan themselves, and we use that to build our model. And so if the data itself is skewed, your model cannot but help be skewed as well. In some sense, as you were saying earlier, the algorithm is not at fault here. It is merely transmitting the biases in the data is collected. By the way, this thing about the data being neutral, I don't know what that means. If you're saying the data by itself doesn't do anything, I don't understand what that statement means. That's why I want to write down that to get back to it, because now I got this point. We want to explain what that means?
So, if I tell you 63%, does that mean anything to you?
Out of context, no, it does not.
If I tell the class that Dr. Parker is going to give 63% of us an A+.
You wish.
She doesn't give grades.
You get what you deserve.
You earn grades.
But if I said that 63% of the people in this room are going to get food poisoning,
Yeah.
that's bad.
Sure.
63% in and of itself doesn't mean anything.
Sure. In that sense, a number by itself has no moral content. That's what you're saying. But all data exists in context, right? There is no one that statement that I don't understand, because in this case, the data is what drives the building of the model, and skew in the data gets transmitted to skew in the model. You got a comment up front?
So it seems like all these conversations are kind of funneling into the same idea of what is the data.
That's one part of it. Yes.
Yeah. Because no matter how much data you collect, there will always be a bias.
Yep. Of some kind.
Of something, because there's always that one extra that we don't know that could factor into this.
Sure.
So, should you try to develop a machine algorithm that produces just a number, irregardless of whatever the person's input is? So every person, let's just say, is represented as a 1. But depending on just the past data, you just take the past data, you can make an accurate prediction. That way, you're including all the data in just...
What is all?
Well, if you're not taking...
So let me tell you a story. So this comes from 5 years ago. The city of Boston. So hold it. The city of Boston was trying to build was trying to get a better way of detecting whether there were potholes in the streets. They wanted to be more efficient at repairing potholes when they came up. So they came up with this very cool idea. They said, okay, we'll build an app. You run this app on your smartphone. When you go over a pothole, the accelerometer in your smartphone will pick up a boop. The app will then send a message to city services. Once these get aggregated, we'll get a map of where the potholes are in the city.
It's not very efficient.
It's very efficient because now there's passive reporting. It's crowdsourced.
Yeah, but what if there's like a path that no one's been on in a while and there's tons of potholes?
So here's what happened. What they discovered mysteriously is that there seemed to be a lot of potholes in wealthier areas of Boston, and they could not figure out why. Any thoughts on why this might be?
Because only wealthier people had access to a smartphone and could track that.
And knew about how to download apps, how to install apps, and do it. It was an innocent mistake. Once they discovered this, they actually changed their strategy. They put the apps on phones used by public service workers, by policemen, by firemen, by other sort of workers, garbage, sanitation workers who are walking all over the city. And then it kind of worked out well. But this issue of getting all the data is why I brought this point up. Right? You have to make sure, you have to know how you're collecting the data. So one aspect, why I'm talking about this here, is that when you talk about the ethical responsibilities, right, of people building software for aiding in, for assisting in decision making. This is one part of it. Where are you getting your data from? How do you know you're getting good data? A lot of the tools for doing criminal risk prediction are built on past historical data. Now, if you believe, as many people do, that there is a historical racial bias in how policing is done in this country, then that data is going to be fraught with problems if you believe that. And then you're using that biased data to build a model which itself will be biased. So one aspect of building a model, this whole issue of, how do I know what my model is doing, is an attempt to understand whether it's doing things that are weird. For example, if you find that your model is for some reason keying off of the second letter of the name of the person to decide whether they should be released on parole, there's something wrong with that model. I don't know what it is, but there's something wrong with this model, and it probably comes from data. But it's not just about the data. Remember I told you about accuracy, about calculating accuracy of how a model works to decide which one to pick? Suppose I have a data set, which is 90% one group and 10% another group. So this happened with Facebook. So Facebook has this policy called a real name policy, where it's supposed to have real names. Now, it's not like there's someone at Facebook checking every new person registered to see if their name is real or not. They have some automated system for doing this. A number of Native Americans found that their names were being rejected as not real. That whatever Facebook system was for detecting real names, their names were being declared not real. They need to come up with a different name. And again, you can imagine how this would work. If you build a system that an automated system to detect whether the name is real or not, it might use certain cues. It might say, okay, if the name includes sort of common English words that are not naturally nouns, or not naturally sort of names of people, then this is probably not a real name. And again, a lot of Native American names have sort of natural words in them. There's one particular. I'll actually send a link out to about the story. Maybe you can add it on Canvas later on. This is in the case where you have a data set and you have a small group here that is different from the main majority. Your algorithm says, I want to be accurate, so I will try to not make mistakes. If the group is small enough, you can make mistakes on everyone in the group, and your algorithm will look great because the accuracy is very high. Now, if your algorithm made mistakes on everyone the same way, that would be fine, but it doesn't. It makes mistakes systematically on one group and not the other. It doesn't know it's doing that, but it just turns out to be convenient to make a rule that works for a large group and not for the small group. And now suddenly your algorithm has failed you because it is giving a distinctly different output to one group versus another. And this is where things get tricky. Because now you have certain small groups being discriminated against because of what the algorithm did. You had a comment?
Yeah, it strikes me that it seems like a problem of the scope of the question that's being asked.
Okay.
Does that make sense? The scope of the question is you want to be able to recognize a person's face.
Yeah.
Then you need to take that scope and apply it to your data and say, like, okay, by a person you need, all kinds of people. You want to recognize a name. If the scope is, like a Western name or an Eastern name or a South American name or what have you. The question, it seems like it's not a problem with the, it's educating today, right? It's not a problem with the data, it's a problem with the scope of the question that's being asked. And it's like, we think we're asking this, so we're getting this data, but then we try to apply it to a larger scope.
I think the problem, and you're right, that it's intrinsically may not be a problem of the data itself, but a problem of scope. The problem is we don't think enough about the scope, right? We just go with whatever we happen to have lying around, literally. And I think that's the issue, that if we thought broadly enough. For example, I don't know if there's some very hilarious rants about, what is the thing, about basically name parsing. I have to find this rant, it's very funny. Like, if you think you know how to parse names, you're wrong. And there's 100 ways, there's a list of 100 things that you might think are true about names that are all wrong when you actually have to parse names. That there'll be 2 names, that there'll be 3 names, there'll be 4 names. For any value of k, that a person will have k names, k parts to that name. All of these things are, it's a very, so this idea of the scope is important. And I think one of the issues that becomes an unintentional, so here's the thing. Why is this an ethical issue? It comes from the following sort of multi-step process. You make certain decisions based on whatever scope you think about. You build a system. The system then, unintentionally or otherwise, systematically affects one group versus another. And that group is affected in a way that is harmful or in some other way makes things more difficult for the group. And generally speaking, groups that are minorities tend to be more affected by these things than groups. And because they're in the minority, they don't form part of the scope to begin with. And so these things tend to compound themselves over and over again. That's where the ethical component of the discussion comes from. It's not that people are saying they're planning to do nefarious things with their code. That's rarely the case. It's that the unthinking and sort of not thought out use of how we write code is what causes all these problems. But let me sort of bring up another complication. These are things that, in principle, we could fix. You have enough data, you think more broadly, you can fix them. There's a bigger issue. Suppose I, in fact, have a process that selects people for hiring. Okay? And there are a lot of systems that do this right now. They will build tools to aid employers by ranking applicants by saying, okay, these applicants, based on a video interview, based on how they talk and what they say and how they sound and how their mouth twitches when they answer a question, we'll build a personality profile of them. And that person, no, you laugh, this is true. They use sort of techniques from the FBI and other sort of do interrogation techniques to this. And then they will build this personality profile, give it to the employer and say, okay, based on this personality profile, based on what you're looking for, we will rank these people a certain way. Okay. Now, here's the thing. There are rules about hiring. Just like there are rules about fair housing, there are rules about hiring. You're not allowed to discriminate against certain groups. So there's this thing called disparate impact that basically says that, for certain, if you're in a protected category, and this is based on, say, gender or race or ethnicity or religion, the likelihood of a positive outcome for you should be similar to the likelihood of a positive outcome for members of the majority group. That doesn't mean that you have the same number of people being hired from different groups, but as a fraction of your subgroup. So if you have, for example, you have 100 applicants for a job. Say 100 applicants for a job. Let's say 90 are from the majority group and 10 are from the minority group. Okay? And let's say there are 10 jobs available. Okay? And you hire 10 people from the majority group and 0 people from the minority group. I think in this case, let's just make it 9 and 1. Okay? Now there's a huge skew in the number of people you've hired, but as a fraction of the group, it's the same fraction. This is considered a fair hiring process. So it's not as if the numbers have to match, but the relative ratios have to match. And they can be slightly off, but they shouldn't be off by too much. They don't have to be equal. You've had bigger numbers, I can show you another example. Now suppose I replace this by code, right? Is this a reasonable thing to do? Should my goal be to ensure, this kind of what I'll call fairness in this legal sense, in this hiring? So in one sense I have to, it's a law, I have to sort of make sure there's some balance in here. Suppose I'm doing something where there isn't law. Suppose I'm doing something like, recidivism prediction. Do I want to measure how different groups are treated? Is it reasonable to say I want the likelihood of releasing people to the same for different groups? So this gets to a whole other discussion of what I'll call sort of fairness. How do you define mathematically what it means to be fair? This is a much more complicated topic. So depending on how you look at it, it's about 2,000 years old. It goes back to Aristotle. You had a comment up there?
Well, one thing I want to say about that is that when you said 90 and 10, was that like percentage of population or percentage of applicants?
I meant applicants.
Oh, applicants?
Yeah.
Okay.
So there are 100 applicants for the job.
That was going to be my first complaint. It's like, no.
Okay.
You want to take percentage of applicants, not of the population.
That's right, applicants.
Because it might be the case that it's just a job where 80%
No, I agree. That's why I said, yeah.
Okay.
So this issue, how do you define what it means to be fair? So this, like I said, this goes back to Aristotle. People have talked about it for thousands of years. Right? This notion of what does it mean to be fair in society. And this is very interesting because you can ask this question from a political science point of view. You can ask this from a sociological point of view. You can ask this from an algorithmic point of view. Fairness means that these two numbers are the same. Fairness means that these two numbers are the same. You can pick and choose how you want to define fairness. But you have to define some notion of fairness if you're going to have a machine learning algorithm that tries to optimize for it. And so another issue that comes up in all these discussions we have is, so I know there's a problem, I know my models are biased, I want to fix them, What am I trying to fix here? Well, the answer is I'm trying to make my algorithms a bit more fair. And there's a whole, again, there's a longer discussion to be had about how you define mathematically what it means for an algorithm to be fair. Whether you want to balance the outcomes, whether you want to balance the relative outcomes, whether you want to balance the mistakes you make. And there's a whole sort of category of discussion that people have had about this, which links to sort of larger philosophical discussions about fairness, which I will not get into. But at any rate, I think what I want to summarize this whole discussion with, I don't want to sort of get into too much of this, is that there is issues of accountability, like I said, understanding what your algorithms do and what happens if an algorithm does something bad. Like when a self-driven Uber crashes and kills someone, who's responsible? Is it the person who wrote the code? Is it the person who deployed who sort of tested the code? Is it the engineer who built the hardware that sensed the data that was put into the code? Who's responsible? That's a question we don't have the answer to. How do you define notions of fairness to ensure that your algorithms are fair? How do you understand what your algorithms are doing? And how do you make sure that people who are affected by these algorithms can actually see what they're doing in the first place? There was a court case recently. So like I said, these tools are being used to decide whether people should be given long sentences, short sentences, what sentences. One person who was sentenced according to one of these algorithms took the case to the Wisconsin Supreme Court. This was in Wisconsin, and said, I was not given my due process right because I have no idea what this code is doing. It declared me a high risk, so I was given a large sentence, and I demand the due process to be able to see what the code is doing, to know whether it was reasonable for it to give me the score. He lost the case, somewhat unfortunately in my view, but he lost the case, where the Wisconsin Supreme Court said, nah, the judge would have probably said the same thing without the code anyway, so it doesn't really matter. But in the future, we should worry about this. They kind of punted on it. But this is again an issue, right? So there are now court cases where the central objects under consideration are algorithms. Whether it's in this case here, whether it's in gerrymandering, or in other cases where people are writing code that is the subject of a discussion whether this piece of code is legal or not, whether this piece of code is fair or not, and people are going to testify about these codes. So I just want to, I want to sort of stop here and maybe have a bit of discussion about this, where I want to sort of summarize by saying, we're now entering an age where the code that we write is being used in places where we didn't really expect that they'd be used. It's having large ramifications for how we live. What the law says, the law is trying to desperately catch up with the code that we write. The lawyers don't quite know how to deal with this. And it's sort of changing our society in ways we don't fully quite understand yet. So in that sense, in terms of our responsibilities towards building such a society, we are, with the code we write, we are actually building what this new society is going to look like. And it's, in some sense, our responsibility to make sure that we do a reasonable job. I think that's where I'll sort of conclude now. But I'm happy to take sort of questions and other comments from you all about all the stuff that you've heard for these last 2 days. Yeah?
One thing that I just thought was interesting, we talked about there being a qualitative aspect. Well, I'll start here. If we had a prediction code that seemed to discriminate against some group of people, it may be discriminating or it may be accurately predicting it, and it's due to some underlying qualitative research that we just don't understand, and I just think that's an interesting aspect.
It is, and in many ways the use of code allows us to make open and clear biases that are existing in society that we didn't realize existed. So in some sense the code can help bring that to the surface, so we can now say, okay, why is it doing this? Is there some underlying issue that we have to address? And that's a good point. So sometimes the code can help be a diagnostic to help us diagnose problems in society as well. Yeah, that's a very good point. Yes?
So does more machine algorithms that are machine learning, if there is that discrimination happening, will they have contingencies within the machine code to kind of create more of a equal distribution?
So that is one solution, set of solutions that people propose. Build things into the code itself to make sure that you have some notion of fairness, which is why you need to define it mathematically so you can do that. That's not the only way to do it, but that's definitely one approach that people have been proposing to try and build different kinds of code. Yeah. Other, yeah.
So at the beginning of the class, you mentioned how, with the case in China, for transparency, they give them an algorithm that's pages of code. Is, in your opinion, that really transparent?
No.
Or should it be given out in a way that the general population can understand it more?
Yes. I think it's a cop-out to just say, here's my 50 pages of code. Because that's not going to be enough. Especially with machine learning, remember, The model, which is the code that's making the decision, comes from a training process and data. Even if I tell you the training process, that won't explain how I got this result if I don't know what the data was. So that's first of all a big problem there. Secondly, just dumping a bunch of code is not going to help me understand why it's making decisions. Right? I can write down, okay, this is the setting for all the knobs to make this happen. Well, why were these settings this way? So I don't buy the idea that just dumping the code is going to help. It's a start, but it's not by any means a solution to the problem. Yes? Stretch, not a hand. Any other questions, comments? Yes?
So, I mean, I guess like for me, this is kind of the first introduction to like ethics inside of computer science that I've seen so far. Why is this, I guess, not a bigger part of many CS curriculums?
It should be. And to be fair, there are a number of courses in ethics in sort of computer science and society writ large that are coming up now all across the country. I taught one last semester as sort of an undergrad class, and I want to do more of this. So I think, yes, I think the reason why Aaron and Mariah have me here talking about this is because they believe that we should be doing more of this stuff. And so that's the point. And it's not just a question of take the ethics class and check it off. I think it's more an attempt to get you to think about this in a more sort of natural, organic way through the work you're doing. In every class you take, I would challenge you to think, okay, what is the ethical dimension to what I'm studying in this class? In many cases, there will be one. You just have to think of it. So I'm glad you brought that up. Any other? Yes?
I'm just curious as to how this ethical discussion has changed over even the last 10 years. Is this something that you've always been interested in and you've always looked into? And if so, like, how have you seen that change over the last 10 years?
So in ethics thinking, I'm about 4 years old. Till about 4 years ago, I wasn't thinking about this at all. I was just doing my own thing. So I'm pretty new to this as well. But I think the thinking has changed very rapidly. I would say the last 2 years. And it's happened primarily because of very public sort of face plants by big tech companies. So for that, I'm very grateful to Uber especially, and to Google and Facebook and Amazon and others for making very public mistakes that have got everyone thinking about these issues. So it's been very recent. In a sense, though, if you go back to the history of the use of science in society, these issues are hundreds of years old. People have been worrying about the use of science and things like eugenics and basics of criminology since the 1800s. But it's almost like these things keep happening. People keep making mistakes. They say, oh yeah, we should never do this again. 20 years pass, everyone forgets, and they start all over again. Some of the discussions we're having right now with the ethics of use of data are discussions we could have had 50 years ago or 100 years ago with eugenics and with phrenology and with feeling bumps on people's heads to decide how criminal they were, right? They were in the 1800s, if you had a long earlobe, you were probably a sexual predator. This was how criminology was done in those days. They collected data and they sort of made decisions based on that. So these things are both very old and very new at the same time. But this discussion has changed a lot over the past couple of years because of the things we're seeing out there. And because of the rapid deployment, I think, of machine learning across the world everywhere, which didn't happen before. So it's all very new. So you're hearing sort of cutting edge stuff in that sense. But it's also very, it's very old in that sense. Other comments? Questions? Okay, I think that's it. So again, I will challenge you to think about these issues in other classes you take, and I'd love to hear your thoughts later on where you think other discussions like this might be useful in other courses we do as well. I don't know if you want to add anything.
Nope. See you next week.
Okay.